part 3, we're still with arrays. And this time we're going to manipulate the arrays in a separate function and display the content of an array in a separate function. The learning objective out of this exercise is to see if we can pass an array to a function and handle it outside of, say, main, right? Okay. So, but let's say we declare that array right here. Let's call it int myArray. Okay. And let's give it a size of 5. Okay. And what we're going to do is we're going to do the data entry for this array outside of main, which means probably we need a function right here. And let's call it void set data. Okay. And let me just put curly braces here. And then we're going to have another function that will print the data. So we'll do something like this, void print data. Now, I didn't put anything in the parameter list for now. I am just putting a placeholder for 2 functions that I'm going to be using. I'm going to call set data here and print data right here. Now, how are we going to do this? Well, I have an array right here. I would like to pass it over here. Now, we could pass the address of this array over to this function. So we need a pointer right here to handle it. Okay, well, the way to do it is int asterisk, and let's call it array ptr. So it's going to receive on this end right here my array. So how do you do that? You're going to call set array and pass my array to it. So technically, let's see if that will work. So my array, the name of the array is the first address of the first element of the array. So that is the address of the array. Good. So we're going to be using the same technique to print as well. Well, let's do something like this. Int asterisk arptr. And the way we're going to call it is print array. And we're going to pass my array. Okay, so in main, you're simply doing 2 operations. Excuse me. One is to call the set array and then print array. Let these 2 functions handle the input and output. So this is why we pass by reference to a function so it can handle it outside and deal with it. So here, and the reason we pass it by reference, okay, we're not sending a copy, we're actually sending the actual array over. And so let's see if we have access to it. So the key now is I have an AARPTR, which is a local pointer variable within set data, okay? And I could use that, okay, to point to where I need to be in that array. So, okay, how would I go about this? Printf, for example, printf, enter a number, right? So we're going to enter a number right here. And we're going to do scanf, and that would be a %d. Now watch this, AARPTR. So there's no point of doing an and% here. It already has an address. And you're going to do this 5 times, but you need to move the pointer, AARPTR++. Otherwise, you'll be stuck in the first element. So we need to do this 5 times. Okay, copy. So 2, 3, 4, and 5. And at the end, there's no reason to move the pointer any further. You are at the end of it. So we should use the same technique to view the array. All right, so this allowed us to enter data into the array. So using that pointer, we should be able to dereference the data that's in there. Sure enough, printf You could say value equal. Or you could say just number. We have 5 of them, by the way. And that would be a %d. Put a /n here. Let's see. And now you need to dereference the pointer. So asterisk AIR PTR. But you need to move the pointer again. AIR PTR ++. We need to do this 5 times. Okay, so we need to do this 5 times. That was a semicolon here. There you go. Copy. 2, 3, 4, and 5. At the end, you don't need to increment any more of the pointer. You're not accessing another memory location you're not supposed to. And let's see how this works. So now I'm going to go ahead and compile and run and see how it behaves. So this is going to be a .c. And I decided to call this one array ex1 abc. This would be D. Let's see. Forgot my semicolons here. Okay. Printf statements have to have semicolons at the end. There you go. All right. So compile and run. And we have a printf situation. Let's see what's going on. Include stdio.h. I put a print instead of printf here. Printf. Of course, there is no function print. Okay, so it's printf. All right, so compile and run. And we have set data. And I called it probably something else. Set array. Okay, so again, that's what happens when you're doing things on the fly. It's called set data, not set array. Okay, and the other one is called print array or print data. So again, make sure you have consistent naming for your functions. Okay, all right, so let's compile and run now. And there you go. So it's going to ask me for my 5 numbers. So a 6, a -2, a 0, an 88, and a 10. And here they are. Okay, so the point of this exercise again is that you can pass a reference or an address to an array. The name of the array is the address of the array. Make sure you have a pointer waiting for it right here. This allows you to alter that array, not a copy, the actual array that you declared in main. And the proof is in the pudding. That means right here, you were able to send the same array over to print data, and you were able to access the same data. So that means you had access to the same values. Okay, so I hope on this you understood now how to pass by reference. Now, if you wanted to know what are the addresses, so if I wanted to say show the addresses for each data member. Now remember I told you each one will take 4 bytes. All right, so we want to see that. Right? I promised you that I will be doing this here. You could do something like this, printf. And then we could say something like this. My array, and we could put an index here while we're at it. Int index equals 0. All right, so we're going to use the index to access it, just like we did with another example. %d here is equals %d, so we could see this in main, and is located at, we're going to look at the address now, %d, and we're going to do a /n here. So we're going to do 3 things. Index for the first one. Next one is my array index. Forgot to put a y over here. And then last one is the address myArray index. So I am interested in the address of myArray at that location. Now, what we're going to be doing is do this 5 times. However, you need to increment the index. So index plus plus. Okay? So we're going to be doing this 5 times. So copy. 2, 3, 4, and 5. And in here, I'm going to do printf show data in main. So we know that's what it's doing here. Let me put a couple /n's in here to separate them nicely. Remember to remove the last index. You don't need to increment anymore. Now let's see how this behaves. Compile and run. Okay, so it's going to ask us for 5 numbers. 44, minus 33, 0, 88, and minus 1. And here we go. So, myArray 0 is at address 2293536, right? That's a location. So what do you think myArray 1's address will be? Remember I told you the offset is by 4 bytes. And you could see that it has moved by 4 bytes. So it always starts with the lowest address since it's a stack. Okay? Right? So 40. The next one is 44, 48, 52. So I hope this proves to you that each integer occupies 4 bytes. Okay? So this is a good exercise to see exactly how an array is stored and where. In this particular example, is it stored in RAM. And the representative first address is 2293536. Now, had I printed myArray as an entity, you will get 2293536. Let's prove that. Okay? So we want to show now that if you used myArray, not the %, to see if indeed it is the address of the array, we could do something like this. Printf, the address of the array is, and we know it's the address of the first element, but we're going to do this, we're going to do it this way. Let me put a /n here also in front of this to give me some space. And we're going to simply say myArray. Now remember, myArray is an address. That was the whole point of being able to pass a reference to a function. Now let's see if that's true. So I'm going to go ahead and compile and run. I must have a running program as we speak. Let me close that first. There you go. Now, compile and run. And let's enter 5 numbers. So 88, minus 2, 0, minus 1, 0, and a 2. Okay, and as you can see, the address of the array is 2293536. So it's the address of the first element. That is what gets passed to the... So, if that's the case, can we see the content of the pointer? The answer is yes. So we could create a pointer, set it, and then increment it and see what happens. So let's do a pointer right here. Let's go ahead and do a pointer. Int asterisk rptr, and I'm going to make it equal to myArray. Right? So next, I'm going to print and show the data that's in there using this pointer. At address, give me a, at address, %d, we have this data. %d, /n. Now watch this. I could do arrptr, which has an address. Next, asterisk arrptr, which is a dereference to that pointer. Now we can do this 5 times, but you need to move the pointer. So AIRPTR plus plus to the next element. So let's see if indeed we're going to get the same data. Copy. 2. Oops. 3. 4. 5. And you can remove the last incrementation of the pointer. We don't need it. Okay. And let me have a whole bunch of /n's. Let me printf /n/n, just so we can separate these logical pieces of the program. All right, well, let's see how this works. Compile and run. Okay, so I'm going to enter 5 numbers: 6, -6, 1, 0, and 22. And here we go. As you can see, the address of the array is 2293520. Sure enough, the first data member is at that address. And notice now, every time you increment the pointer, you increment by 4, even though we said AARPTR equal AARPTR plus 1, right? That AARPTR plus plus is really an arithmetic addition of 1, but what you're adding is 4 bytes. And it's dereferencing for us also what's at that location, what's being pointed to by the pointer. That's your 6, -6, 1, and 0, and 22. Those are the asterisks AARPTR. Okay, so I hope with this example, I've clarified a lot of concepts in terms of how to use arrays, how to pass arrays to functions, how to use pointers with arrays, and understand the mechanical aspects of how an array works or lives, right? So on that, thank you.